Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and I am back with a new tutorial. Currently we are studying Marine Auxiliary Systems and Deck Machinery. Today we are going to discuss automation and alarms in purifiers, methods of oil purification and optimum throughput rates. First, we will go through the fuel oil clarifier piping layout. Next, we will understand the automation in purifiers and clarifiers. After that, we will discuss the typical alarms in purifiers and clarifiers. Then we will learn about the methods of oil purification. And finally, we will understand the optimum throughput rates. Let us begin with the first topic. Fuel oil clarifier piping layout. This sketch shows the piping layout of fuel oil purification system consisting of two clarifiers, two fuel oil supply pumps with oil heaters, all connected to the fuel oil settling and service tanks having steam heating arrangement. Heavy fuel oil is supplied from bunker tanks to the settling tank through the transfer pump. The temperature of the fuel oil is maintained at 75 degrees Celsius by the steam heating coil. Fuel oil supply pump number 1 takes suction from settling tank and discharges oil to fuel oil heater number 1. The oil is heated by steam and its temperature is automatically controlled by temperature controller TC. The condensate is returned to the hot well through the steam trap ST. The oil is kept in circulation through a three-way valve 3WV via the recirculation line. Supply pump number 2 and oil heater number 2 are kept on standby. The supply pump suction filter is cleaned on a monthly basis. When the clarifier attains its rated speed, a command is given to the control panel for automatic operation, which feeds oil through the three-way valve. The oil throughput is regulated by a flow control valve FCV. The clarifier discharges clean oil to the service tank. A back pressure valve BPV is used to maintain the required back pressure. A water transducer WT continuously monitors the water content in the clean oil and operates the water drain valve at the preset level. The clarifier intermittently discharges sludge and accumulated water through the discharge timer. Then restart the operation automatically. The settling and service tanks are located side by side so that excess oil from service tank can overflow back to settling tank, keeping the service tank always full. When necessary, purified heavy oil is reheated by the steam heating coil. Automation in purifiers and clarifiers. The centrifuge is started manually. Once it attains the rated speed, the controller is switched on for automatic operation, which includes the following functions. Temperature control. As per the set point, PID temperature controller automatically regulates the flow of steam passing through the oil heater to maintain the desired temperature at the heater outlet. Automatic start of purifier. When the controller is switched on, it supplies power to the solenoid valve to close the valve. Next, it supplies sealing water to the solenoid valve for a specified duration. It then starts the oil feed by changing the position of the three-way valve and begins monitoring the back pressure at the clean oil outlet. Automatic start of clarifier in the LCAP system. When the controller is switched on, it supplies power to the solenoid valve to close the valve. It then starts the oil feed by operating the three-way valve and monitors the back pressure of the clean oil outlet. Water discharge in LCAP system. The water transducer continuously monitors the water content in the clean oil outlet. When the water content exceeds the preset limit, it activates the water drain valve for a specified period. Intermittent discharge in LCAP system. As per the set interval, the controller supplies valve opening water through the solenoid valve for a short duration to discharge sludge intermittently without stopping the oil feed. Total discharge in purifier. As per the set time, the controller closes the oil feed supply by changing the position of three-way valve. The controller then stops the valve closing water and supplies water for opening the valve. To continue with the purification again, sequence for automatic start of purifier is repeated. Typical alarms in purifiers and clarifiers. Several alarms are designed to warn the engineer of any malfunction or abnormal condition during purifier operation. High or low oil temperature alarm. A temperature sensor continuously monitors the oil temperature after the oil heater. If the temperature goes beyond the set limits, either low or high, an alarm is initiated. Such a condition may occur due to low steam pressure, a malfunctioning temperature controller, or a leaky steam valve. Low oil feed pressure alarm. During operation, a pressure switch monitors the oil pressure in the feed line. If the feed pressure drops below the set value, an alarm is triggered. This may happen because of clogged oil strainer, low oil level in the settling tank, incorrect operation of the three-way valve or flow control valve, or failure of supply pump. Operating water tank low level alarm. If the water level in the operating water tank falls to the low level sensor, an alarm is initiated to alert the engineer. Possible causes include leakage in the operating water line, a stuck filling valve, or low pressure in the domestic freshwater system. Bowl not closing alarm. When bowl closing water is supplied, the sliding bowl lifts up and seals against the bowl hood. A position sensor detects this condition before sealing water or oil feed is supplied. If the position is not confirmed, a bowl not closing alarm is generated. This may occur due to insufficient closing water pressure caused by blockage in the line, leaky seal rings, or worn valve plugs in the operating slide. Seal failure alarm. If the back pressure in the clean oil outlet falls below the set point, a seal failure alarm is initiated. At the same time, the three-way valve automatically shuts off the oil feed to prevent oil loss. The likely causes include leakage of sealing water, high operating temperature, incorrect feed rate, or heavy rolling or pitching of the ship. Sludge discharge failure alarm. The purifier detects sludge discharge either through a micro switch activated by a striker pushed by the sludge or by an increase in motor current caused by a momentary reduction in the bowl speed. If, after supplying bowl closing water, no such signal is received, a sludge discharge failure alarm is initiated. This can occur due to blockage in the bowl, opening water supply, or leakage of seal ring in the operating slide. Water transducer fault alarm in LCAP system. In the LCAP system, if the water transducer fails to provide an output signal, the control panel initiates a water transducer fault alarm. This may result from a broken connection or a defective transducer. Vibration or imbalance alarm. If vibration levels rise during operation, the vibration monitor detects it and sends a signal to stop the purifier. An alarm is then initiated. Common causes include uneven or excessive sludge accumulation, worn bearings, or loose components. Motor overload alarm. When the purifier is started, the electric motor draws a high current until the bowl reaches its rated speed. During this period, the overload relay remains bypassed. However, if the motor draws high current during normal operation, the overload relay trips, stopping the motor and raising an alarm. Motor overload can result from mechanical defects such as worn bearings, unbalanced bowl operation, or unbalanced electrical supply. PLC or control system fault alarm. If any malfunction occurs in the control system, it automatically shuts down the purifier and raises an alarm. Electronic control systems also perform self-checks during operation. If a fault is detected, a passive failure indication appears on the display, which may be due to a loose or broken contact or a defective component. Methods of oil purification. Oil can be purified by one of the following methods. Batch purification method. This method is mainly used for the purification of fuel oil where the complete oil is passed through the purifier before it is supplied to the engine. For fuel oil. In this process, unpurified oil is first transferred to the settling tank. From there, it is supplied to the clarifier for purification. The purified oil is then delivered to the service tank, from which it is finally supplied to the diesel engine. For lubricating oil. Now let's look at batch purification, which is generally used for lubricating oil. This method is adopted when the lubricating oil becomes unsuitable for use due to heavy contamination with water or the formation of thick emulsion. In this case, the entire sump oil is transferred to the settling tank provided for such situations. The temperature of the tank is raised by steam heating and any settled water is drained off regularly. Once this is done, purification is started with both suction and discharge from the same settling tank. The purification process is continued and the oil is tested at regular intervals until it is found suitable for reuse. After purification, the system lines are drained and the engine sump is thoroughly cleaned. If the void has to continue immediately, a fresh oil charge is used. Otherwise, the old oil is reused after successful batch purification. Continuous bypass method. Lubricating oil purifiers for propulsion engines and turbines are usually arranged to operate on the continuous bypass method, which we will discuss in the next slide. Oil purification by continuous bypass method. This sketch shows the layout of oil purification by the continuous bypass method. The oil sump is divided into two compartments. The engine drains the used oil into the first compartment, which then overflows into the second compartment. The oil in the first compartment is relatively dirty, from where the purifier supply pump draws oil and delivers it to the purifier through a heater. The purified oil is discharged into the second compartment. The main lube oil pump takes suction from the second compartment near the clean oil outlet of the purifier. In this way, the quality of oil is maintained in a satisfactory condition. Optimum throughput rate. This sketch shows the relationship between impurities in engine lubricating oil and the throughput rate of the purifier. it is of utmost importance that purifier throughput rate is carefully selected, as the optimum rate leaves the minimum contaminants within the system. As a general guideline, the optimum lubricating oil throughput rate is approximately one third of the maximum throughput rate of the purifier. At this throughput rate, the purifier should be capable of handling at least twice the system oil every 24 hours. If the water content in lubricating oil exceeds 0.1%, the throughput should be increased until the water content is below 0.05%. Under normal operation, it is recommended that after shutting down the main engine, the purifier should be kept running for 12 hours to minimize corrosion caused by acid vapors condensing as the engine cools down. During short port stays, lubricating oil is always kept operational as long as heating is available. In the case of fuel oil purification, the optimum throughput rate should be 5% above the engine fuel oil consumption so that the service tank level is steadily maintained. This completes our study of the layout of fuel oil clarifier piping, automation in purifiers and clarifiers, typical alarms in purifiers and clarifiers, method of oil purification and optimum throughput rate. This book has been written by me and covers all the topics as per the syllabus specified by the Indian Maritime University. It explains the concepts with simple illustrations and provides answers to all the questions that have appeared in the examination conducted by Indian Maritime University. This book will help students prepare for the exam and also assist them in working safely with shipboard, auxiliary systems and tech machinery. I hope you enjoyed the lecture. Feel free to share your feedback in the comment box. If you found the tutorial helpful, you may share it with your friends. You can also subscribe to the channel to receive notifications about upcoming tutorials. I'll be back soon with another lecture. Thank you for watching till the end.